back of your worksheet practice A 1.1. We're probably going to do problems 21 through 24. Number 21 says name 8 different rays. So we're going to use this diagram. And you can name a bunch of rays. So 8 might seem like a lot, but I think we can do much more than just 8. Just remember, when you name a ray, whatever point you're starting at must be listed first, and you're going in the direction of the other point forever. So this ray right here, starting at Z and going towards W forever, we would name that ray ZW. And the way we write that looks like this. That's the shorthand notation for ray. You always point the arrowhead to the right. And that makes sense because our ray is going to the right. But what happens if you wanted to name this ray? That's going to be ray ZX. But I'm still going to point the arrowhead to the right. That way we're all on the same page with the notation. It would get really confusing if we start pointing rays up in our shorthand notation. That's why we always point to the right. So if we just keep going around the horn here, this would be ray ZV. And this would be ray ZY. Now there's 4 rays. Are there more? Sure. Is there any other way to name this ray ZY? There isn't, because there's no other points in between Z and Y, or after Y. But if we came up here to X, we could name this ray XY. That's a longer ray than ray ZY, a different ray. So I called that ray XY. Now here's where we can talk about other names for ray XY. It starts at X, it goes forever towards Y. What if you named it ray XZ? It starts at X, it goes forever in the direction of Z. So that's another acceptable name for this ray. Okay, so we need other rays. We still need 3 more. How about ray VW? We could go the other way. Ray WV or ray WZ. That would be the same ray, different name. And we need 1 more. So obviously if I start with a different endpoint than these letters, maybe I'll start with Y. That's going to be a different ray. If you have a different endpoint, you're going to have a different ray. We'll call this ray YZ. That continues on in that direction. Now I could have named other rays here, but they only asked for 8. Name 2 pairs of opposite rays. Again, there's options here. These rays are opposite. They make a line. They have the same endpoint Z. So I'll say ray ZW, and I'll say ray ZV. Those are opposite rays. The other ones would live here. Ray ZY, ray ZX. Number 23. Name 2 lines that intersect at point Z. Well, do you see the 2 lines in the diagram? They intersect at point Z. You just need to name those lines. And again, there's options. How do you name this line? Okay, you use 2 letters. Pick any 2 points that are on that line. There's infinitely many, but 3 of them have names. You pick. We'll call this line VW. And again, notice it's a line, so I'm putting 2 arrowheads. And then the other line would be this one. You pick which 2 letters to use and put them in any order you want. The order of the letters doesn't matter. I'll call this line XY. Again, it's a line, so I'm using the notation. If you switch these orders, it's okay. If you wanted to put a Z in here, you could. If you wanted to put a Z in here, you could. Number 24, we're going to draw 3 non-collinear points, A, B, and C. So maybe I'll just stop there. Those 3 points are non-collinear. I can't connect them with a line. We're going to sketch line AB. So we just connect them. We have a postulate that says any 2 points could be connected with a line, so we just did that. We want to put point D somewhere, add point D, and sketch line CD so that line CD intersects line AB at point B. Okay, so we want a new line that's going to intersect line AB at point B. So I'm going to kind of do this. So that's where you might want to read ahead. So maybe just reading it piece by piece wasn't a good idea. Maybe you should read the whole thing first. So here is that line, and we'll put D on here. Add point D so that line CD intersects line AB at point B. Yeah, so here we go. Here's line CD. It intersects line AB at point B.